All right, the next is company number 7, COGNANO, and the speaker is Mr. Akihiro Imura. And sorry, we are just preparing the slides. One moment, please. Okay, then now the presentation is ready. Thank you very much. The floor is yours.
Hello, everybody. I'm Akihiro Imura from COGNANO, a tech bio for new AI drug discovery. Before my presentation, let me share a very interesting movie, Moneyball. Moneyball is a very interesting movie focusing on the importance of statistics and mathematics in business. So the manager of weak team consider what is the correct way to win. So the old style repetitors and consultants are recommended power no shoulder or a strong power and batting and home runs. No, he rejected the opinion and he hired a mathematician from Yale University and he employed statistics and as a result, they won 20 serial games. That was a record, world record in history. Thank you for patience. So, I mean, we have to say goodbye for old bio and old medicine. I want to go for new biology based on big data, statistics, and algorithm. Okay, here is my team. COGNANO composed of 3 bio experts and 3 IT engineers. And we are collaborating with Google and AI top consortium named OpenFold, as well as global universities. Here is market size of oncology. And within 8 years, the scale amount will reach 600 billion. Let me remind the original story of biodrug. 30 years ago, Dr. Schreiman focused on the target molecule named HER2. The drug name was Herceptin. That was approved 1998. This is the beginning of biodrug history. However, for 30 years, we have no new HER2 still now. So we have no apparent target like this. This is the largest pain in pharmaceuticals, in my thoughts. So there are so many candidates of target molecules for cancer drugs, such as HER2, TROP2, or Claudins. However, they are also expressed on the normal cells. This is the cause of side effect. Okay, in general, on the cell surface, there are so many molecules. So, which is which? This is which is the appropriate target, next target. So, nobody knows. So, we decided to dive deeper. We develop a new technology of digital information of structure. This is nanoscale. And next, Angstrom scale. This is the surface of molecule. There are so many structures, but nobody knows the structure. However, we developed a digital probe of structure using the VHH antibody technology. This is a key or probe for subtle structures with digital label. VHH antibody is a small compound from camelid animals, and this is a very useful tool and easy to be read by next generation sequencer. our bio team accumulate day by day the big data of antibody coding genes from alpacas. And IT team analyze which is the new drug or which is the hopeful novel target. So the principle is very simple. The protein and antibodies are written in alphabetical letters because they compose of amino acid residues. So natural sentences seem like human sentences. So they are corresponding to each other. So fortunately, they are understood by large language model like ChatGPT. Yeah, gotcha. So we collaborate with Google and new OpenFold, and this achievement was accepted by top AI conference, New Rips. And further, of course, we wanted to confirm the efficacy in animal model. So we eventually found new biomarkers on TNBC, triple negative breast cancers and pancreatic cancers, and we made in-house drug, ADC drug, using these antibodies, and we tried to inject in mice, and the evaluation was 2,000-fold efficacy in comparison with ordinary drug. So we are launching serial ADC drug and novel as well as novel biomarkers every half year. Repeatedly, we are aiming disruptive innovations, and our product is not only drug but also novel target. And we hope, in our hope, ROI should be more than 30 times. This is our business model. We are collaborating with IT techs and universities in the world, and based on our patents, we a collaborating team launch product as well as joint ventures that would be supported by government. And within 3 years, JV will get exit. And eventually we got a big return from the exit, and we will provide a big return for investors. Okay, this is a final slide. Today, everybody can get access to any destination in the world. Similarly, every pharmaceuticals can get any novel targets on the cells or on the molecules with COGNANO map. Please feel free to ask and join COGNANO. And we are looking forward to hearing any interest from you. Thank you so much.
Thank you very much, Mr. Imura. Okay, so now we are moving on to the question. If any company available? Anyone from the floor? And if you're joining online, please use the Q&A function if you have any. Anyone would like to raise question? Okay, from gentleman from the rear. Thank you very much.
Let me speak in English, Japanese. Thank you for your presentation. So the target and the antibody, so they are matching. I think you had the slide. Could you show? Oh, yes, this is a slide. So could you elaborate this slide? Yeah, sorry, I just provided a very simple idea only. So basically, antibody and the antigen are matching one by one. And there are a lot of antibodies and antigens as well. So which ones are corresponding? So that is very difficult to figure out. So that's why we use big data as machine learning sequence. Well, based on the sequence, we can find out the correspondence. In addition to that, cancer cell and normal cell, when we compare them, there are some antibodies which have affinity with cancer cells, and we can extract it. So we invented this technology. But it's a bit complicated concept. So if you are interested in, I can provide more detailed information.
Thank you very much. As